Eric Darling here with Darling Data, and in today's video we're going to talk about code patterns that are sensitive to concurrency under just about any isolation level, really, at least in the absence of transactions and potentially usually additional locking hints. So in general, to little mix of recap and some new stuff. I find the use of optimistic isolation levels a lot smarter than pessimistic ones for, let's just call it the gen pop of workload queries, because the behavior to me is reliable in a better way. The default pessimistic locking mechanism for read committed leads to a lot of terrible blocking problems between read queries and write queries, not just write queries, which can cause a lot of pain for end users. And like I've said before, any isolation level that's so bad that it leads people to using things like read uncommitted or its synonym no lock as a best practice when writing queries has to be a really bad situation, right? It's not a good thing. Read uncommitted makes almost no guarantees as far as what data your query will return. Remember that read uncommitted and its synonym no lock are much better described as no respect, because they have no respect for locks taken by other queries, which means that you can return in-flight data from transactions. That's what a dirty read is. Read committed makes very flimsy guarantees, though it does cover up the dirty reads part, or does patch up the dirty reads hole, which is, man. The guarantees that it makes as far as data consistency are quite flimsy. We've gone over that in a few different demos now. So if you haven't watched the other videos in the series, please do watch those so you can understand just how flimsy the read committed guarantees are. Repeatable me. I like to think of myself as repeatable. Maybe that's going to be my movie. So instead of Despicable Me, it's going to be Repeatable Me. I don't know what I'm going to say though. It does make less flimsy guarantees than read committed. Again, we looked at how that works, where it locks the key values that you've read in a transaction, right? So you begin tran, read some rows, the key values get locked, but you're able to make changes around all those key locks, right? It allows things in between to happen. Serializable, again, patches that hole a little bit by locking not only the key values that you've read, but also the space between them so that you can't insert new rows in. The problem with repeatable read and serializable is that you will run into most likely run into a lot of additional blocking and deadlocking issues that you would not run into even under read committed, but I think better, like you wouldn't run into them under an optimistic isolation level. Plus you wouldn't, like, there's even stuff that you would get, like, data consistency wise, that you might prefer over a locking pessimistic like isolation level. There are many unexpected things that can happen under concurrency with almost any isolation level, even pessimistic ones. Let's go through some of the examples here. Read uncommitted guarantees that table definitions won't change while your query runs. Schema stability locks will prevent that from happening, right? So you won't be able to change indexes, the table definition, add columns, drop columns, that stuff. Read committed guarantees what read uncommitted guarantees, plus the additional issue of your read queries both blocking, being blocked by, and deadlocking with modification queries. This may be desirable if you're doing something weird like managing your own sequence tables. That got cut off a little bit, so there you go for that. Or if you're writing code that is working in a queue. So like if you have a queue table and you have some sort of process that grabs, if it's a single threaded process, it almost doesn't matter. But if it's a multi-threaded process, that's where you would probably see problems under an optimistic isolation level that you wouldn't see with read committed locking. the thing with like the queue table process is that for most queuing things, whether it is, it doesn't matter like if it's first in, first out, last in, whatever. It almost doesn't matter. What can matter a little bit is how the queue is resolved. So sometimes you might delete items from a queue after they've completed. Other times you might update a column to say this row is completed. So there are different ways of approaching it, but just about any well-written queuing code is already going to have some locking hints in it anyway to allow the queue to make progress when certain rows are locked. Like almost certainly going to have like a read past and row lock hint. Maybe even like, depending on how you're doing it, you might even, have like an upd lock, hold lock hint so that like whatever row you select, the locks hold there and other things use read past to get beyond that row, right? So read past can actually be a very valuable hint for those scenarios. Repeatable read gives you the guarantees of read committed plus some other stuff. Data won't change during the transaction, but it doesn't prevent new rows from being inserted or updates from changing rows to like go in between your key values. It will only prevent changes to rows once they're read and only prevent those rows from being changed. Serializable goes a step further, guarantees all the previous stuff, plus it will, using key or range locks to prevent phantom reads, it will lock like if you have if you have key values 1 and 3, you won't be able to put a 2 in there. Or under like repeatable read, you'd be able to put a 2 in there. It's not a snapshot in time from the start of the transaction. It's a snapshot in time from when the transaction commits. All right, so that's the important sort of thing to get there. Excuse me. Yeah, something got stuck in there. We're good now. Serializable and snapshot are the only ones that do not allow for dirty, non-repeatable, and phantom reads. No locks or its synonym read uncommitted is the only one that will allow dirty reads, but both read committed snapshot isolation and snapshot isolation do allow non-repeatable and phantom reads, as well as repeatable read 2 for some like in-between scenarios. The difference between optimistic isolation levels and pessimistic read locking isolation levels is that depending on your use of transactions and the placement of queries within transactions, like snapshot and read committed snapshot isolation might see stale data from versioned rows. That's not a dirty read. It's just data that is maybe older than you would anticipate, than you would end up reading if you were using a pessimistic locking isolation level. So those row versions, they exist for different spans of time depending on the isolation level you're using. But we're gonna talk specifically about how snapshot is different from read committed snapshot isolation. So don't worry too much about that point right now. We're going to get to that in detail. The point is, again, no isolation level is perfect. All of them have trade-offs, and isolation level subtleties surprise a lot of people when they start digging into them and getting beyond just what happens in like 1 or 2 query windows. There's a lot of hysterical blogging that's been done about incorrect results under optimistic isolation levels. But what a lot of those posts leave out is that a lot of those incorrect results are absolutely 100% possible under other isolation levels, just at different points and to different degrees. It's not completely unfounded, but it's usually overblown when you think about the vast amount of good that optimistic isolation levels provide and the number of problems that they solve without you having to make vast changes to code and indexes. And even if those changes are available, you still might end up in a bad situation. The behavior of serializable as an isolation level is often what people think using the default read committed isolation level achieves, but that's just plain wrong. If you're using the default read committed pessimistic isolation level and you don't have no lock hints everywhere and you're not setting every isolation level to read uncommitted, even simple query patterns can cause issues. People will often only associate these issues with optimistic isolation levels, wrongly thinking that this can only happen when row versioning is in play. Sometimes blocking will, under a pessimistic locking isolation level, sometimes that blocking would give you more up-to-date results than you would get under an optimistic isolation level. But often the amount of pain that comes along with that is pretty difficult. It becomes pretty difficult to defend the pessimistic isolation level read committed when you start seeing those problems really tick up. And again, it's not no lock and read uncommitted that are the problem. The problem is read committed, because the problems people face under read committed are so bad that they think no lock and read uncommitted are suitable alternatives to avoid those problems. There are some code patterns that can give you unexpected results under any of these. Oops. For some reason this keyboard. I wish I had a kiwi bird. So under some circumstances, these the code patterns that we're about to talk about can give you unexpected results under these isolation levels. Probably not under snapshot or serializable, but under serializable you would have a lot of additional locking, and under serializable you would still have the slight chance of either reading stale data from the version store, depending on how many queries are involved in your transaction and when the timing of those queries. And also, if you maintain the snapshot isolation level for your modification queries, you also would have to start dealing with conflict detection. Conflict detection is not something that I'm covering at all in this. Aside from saying the words, it is far too complicated of a subject to get into in this series. So we're not doing that here. There's actually a fair amount of learning that I would have to do in order to accurately and adequately present that to you. And I just do not have the time or energy to fully dig into that right now. So aside from the knowledge that I already have about it, I know that there's a lot out there that I would have to get into to make sure that you had a complete picture of it. So let's say that you're using the default read committed pessimistic isolation level. And let's say that you begin a transaction and you run a query to find the most recent ID where the last access date is greater than or equal to the max last access date in the users table. So essentially you're doing sort of like an uncorrelated self-join. I mean, just, it's greater than or equal to. So it's not like the last access date per user. We're just finding the most recent user, right? So let's say we do something like this. We have two opportunities without any locking hints or without any setting any isolation levels for SQL Server to read data. Again, this is under pessimistic read committed, that might change all around when this query is running. So even if this query is very fast, you could still have rows mixing up and moving around in there. So we have a read that will not escalate to an object level shared lock or hold locks on anything here, and we have a read that will do the same thing here. Now I've added in some cases where adding in these locks would help you avoid that in the context of a transaction, but very few people are willing to sacrifice concurrency for this sort of thing. Now, so we already have two places in this query where you might have read committed betray you and return weird data. Now, just pretend that we run this and we fetch this next user ID here, and then after that query runs, without those locking hints in place, without that transaction in place and all this other stuff, let's say that we want to award whoever was the most recent login with 1 million reputation points. Well, someone could log in right after that, right? You say the contest deadline is at blah, 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 and someone just snakes in at the very end. Well, you would miss that person. You would incorrectly award 1 million reputation points to the wrong person, right? Because your data could be changing as that query runs and after that query finishes without suitable locking hints. So that's one place, and this is, I want to point out before I go much further that a lot of the code patterns here are ones that people ascribe to getting weird results with an optimistic isolation level, where it's just as possible with a pessimistic isolation level without suitable locking hints and using transactions. Temp tables are another one. So let's say that we insert data into this temp table here called update. We have the same situation as above, where we have two reads from a table, where under read committed, data could be all sorts of weird and funky, like as we're reading it, like this data could change and rows could move around and we could miss rows or see rows twice or all sorts of other things. And let's say that after we get that data into that temp table, and don't get me wrong, I love temp tables. Temp tables solve many, many problems that would be almost impossible to solve without them. So they're great things. I'm not trying to dissuade you from temp tables. What I'm trying to point out is that under proper concurrency and without proper uses of transactions and locking hints, just about every coding pattern that you have works by pure luck, right? Which is not a great feeling once you really understand it. But a lot of this stuff will not work without you going and doing crazy things to make sure that things happen in a more isolated, locked out fashion. So we put that data into a temp table, and then we use the data in that temp table to update an actual table. Well, the data in that temp table could change between when that query finishes and when we do this update, so that we would be working with stale data here. Now, to backtrack a little bit, let's say that we did have these locking hints in place, right? And let's say that, like, we got this data, but then while we were getting this data and we took locks, right? Let's say we had update lock and serializable locks on this. Let's say that we did this, and we had another process try to update the total score by user table to say, no, we have a new high score for this person, right? This person just got a higher score. We need to change this. That query would be locked out, so we would be working with stale data anyway, right? So it's very, very difficult, depending on what your expectations are of the results of these queries, to say, yes, this is exactly how data should have been at the time that this ran and got this data. So I don't know. There's a lot that you have to consider and be aware of, and you have to sort of set expectations for yourself and for your users as to which data they are seeing. Even if we were just to do a straight update, now here we have 3 references to total score by user. The only one that is actually going to result in locking is this one, right? When we actually do the update, because when this update starts performing its updateness, that's when locks get taken. Before that, when we read that data, or when we read the data from down in here, these are just like in the other examples. These are completely prone to the perils of read committed, the pessimistic isolation level, and absent a transaction and suitable locking hints. What happens, right? Either you're working with data that is allowed to change underneath your query, or you are locking out other queries from changing data and working with stale data. It's a very, very, I believe in the words of Paul White, it's a very, very woolly scenario. He might have better words for it, but woolly has stuck with me. And let's not forget our friend merge. Under merge, you can have an update and an insert and a delete, and those inserts, updates, and deletes might happen at different points under different operators in the query plan. At bare minimum, you need to have a serializable hint issued against the target of your merge when you have multiple actions in there, in order to guarantee correctness. My friend Michael J. Swart, lovely Canadian fella, has a lot of great blog posts about concurrency in general, but a lot about upsert patterns. So either using merge directly or using insert, update, and delete in separate constituent queries to perform similar tasks, right? And he has a lot of great material on that stuff. I would highly suggest, if you are not already following Michael's blog, you're not already subscribed to that, please do. Please go back through his archives and read. I have learned so much from Michael over the years. It's ridiculous. So please, if you're not already doing it, do it now. All right, it's for your own good. So merge is another example that's pretty well a disaster. But the point is that all of these issues are related to timing and concurrency, and it's up to you to make a choice between like which of those you want to win out. Right? Either you want the query results to be exactly accurate for when your query ran, in which case you need to block changes to those tables, or you need to be okay with the fact that as soon as your query runs, what you just saw might be out of date. All right? If you have a very highly concurrent workload, the more chances you have of the data that you're working with being out of date. Pessimistic isolation levels do give you more up-to-date data. The blocking and deadlocking problems between read queries and write queries with them is a pretty horrible trade-off for that for a lot of the workloads I see. Most often, snapshot isolation and read committed snapshot isolation are better choices in general, but again, not every isolation level or rather, no isolation level is going to be perfect for every, the entirety of every workload. Some third-party applications are written with a lot of locking hints built into them. So even if you have an optimistic isolation level enabled, you're not going to be able to solve every blocking problem. If you want queries to be blocked so that they get more recent versions of data than you would get with an optimistic isolation level, then stick with read committed and add repeatable read, serializable, and even up-delock hints and other stuff where it's necessary. If you're okay with queries using version data, like the last known good version of a row, that definition does change a little bit between snapshot and read committed snapshot. But if you're okay with queries using that row version in order to have them just be able to make progress and run, not have read queries block write queries, not have read queries deadlock with write queries, not have write queries block read queries, you're much, much better off under an optimistic isolation level where you avoid all those awful scenarios and you still get what is most likely going to be in like 99% of cases the same query results. If you're okay with queries returning absolute potato face nonsense, you are of course free to keep using no lock hints. There are some things that you do need to be aware of or be wary of, be cautious of if you're using optimistic isolation levels. Things like long-running modification queries, particularly updates, and sleeping queries that have performed modifications, right? Because it just prevents the cleanup of row versions and stuff like that. Anyway, this video went on a little bit longer than I expected, but that's okay. You got nothing but time anyway. So I'm going to put this one in the upload queue, and the next thing that we're going to talk about is snapshot isolation versus read committed snapshot isolation. I realize that's something that I've been teasing for a little bit, but we're going to talk about I think the primary difference between those two as far as what data gets returned in there, because I think one thing I talked about earlier was that read committed snapshot does allow for non-repeatable and phantom reads, whereas snapshot doesn't, and we're going to look specifically at that. So anyway, hope you enjoyed yourselves. I hope you learned something, and I hope that this video wasn't too long for you, because some people do complain about my length, and gosh, I feel guilty when I've given you too much information in one video. Really makes me feel sorrow. So makes me feel guilty. Like, oh, I've informed you too much. I've given you too much information. You poor thing. You might have to hit pause and come back to it, or rewatch certain parts. You wastrel. Anyway, all right. Whew. I'm all out of breath now. I'm all worked up. Anyway, thank you for watching. Goodbye.